Hello everyone. In this video we will cover abstract factory design pattern. Now this design pattern is very similar to factory method design pattern and I have covered that design pattern also in my last video. So I would highly recommend you to watch that video before starting this one, and you will find the link to the video in the first link in the description below. So please watch that video if you haven't, and then you can start with this. So with that, I think we can get started. So in this video, we will cover first of all what is abstract factory design pattern, why we use it, how to achieve it, right? Code implementation in C++, then its benefits and its disadvantages, and in the end, difference between factory versus abstract factory. As I already told you, this design pattern is very similar to factory pattern. So we will see also what is the difference between the two. So let's start that what is abstract factory design pattern. So first of all, it's in the category of creational design pattern, right? There are broadly three categories of design patterns, and it provides an interface for creating families of related or dependent objects without specifying their concrete classes. So it is just sort of a formal definition. We will see what this means, but what it is hinting at is it provides an interface for you to create family of related objects, right? And it is an extended version of factory pattern. So we have already discussed this, that it extends the factory pattern, and we will see how. It also follows open close principle, which means it is open for extension and closed for modification. That also we will see how it does that. Now, so let's start with why use abstract factory. Let's consider a scenario. Let's say you want to start a furniture factory, and for example, right now you just want to manufacture chair, sofa, and your coffee table. So these are the three products you want to manufacture, but you want to manufacture their variants also. For example, you currently want to manufacture in two variants. One is the Victorian style, which looks like this, and a modern style furniture, which looks like this, right? So we can say Victorian, we can consider them as families. So we have a Victorian family furniture and modern furniture family, right? And in Victorian we have three type of furnitures: chair, sofa, and table. Similarly in the modern style furniture. So let's say we have this, we have to create classes, we have to create a program which can simulate this. So first of all, what we want is we want grouping of different products of a same family. So abstract factory enables the grouping of the different products of a same family. So it will provide you a way in which you can group all the products of a Victorian style into one, and similarly another in the modern style. And using this, introducing new type of products or family of products in future becomes super easy. For example, if you want to manufacture a lamp also in the future, so it will enable you to extend your factory with creating lamps. Or you want to introduce a new variant of the furniture, some different style, you can introduce that also with very little changes in your code. So let's see how to achieve this. So we have taken the same example. So now what it will do, first it will create a furniture factory. Before that, we should create each product. So we had three products right now: chair, sofa, and coffee table. So we will first create the interface of type chair, sofa, and coffee table, and it has a function which is sit on, sofa also sit on, and coffee table in which put coffee. Now, all of the different variants of the chair, sofa, and coffee table will implement this interface. So we will create one Victorian chair, one modern chair, similarly one Victorian sofa, Victorian coffee table, and modern coffee table. So now these are our concrete classes which has implemented these interfaces. Now this is the main class or main factory. We call it's also an interface. It's a furniture factory. So furniture factory can create chair, create sofa, and create coffee table. These are all functions which will implemented by the concrete factories. Now we will need two factories, two concrete factories. One is Victorian factory and modern factory. Now if you notice, Victorian factory will implement these three functions which was in the interface: create chair, create sofa and create coffee table. And they return the chair, sofa and coffee table type object. But if you see, when it will create a chair, it will create a chair of type Victorian chair. Similarly, Victorian sofa and Victorian coffee table. Similarly, modern furniture factory will create the objects of modern furniture. So modern chair, modern sofa and modern coffee table. So with this, the client doesn't need to worry about which factory it is dealing with, and the factory will create which type of product. So for example, if a client gets a factory of Victorian type, so whenever client will do create sofa, it will automatically get a Victorian sofa. It is guaranteed to get a Victorian sofa and not modern sofa. And client doesn't need to know all of this. Client just do create sofa, it will get create sofa of a appropriate type. And as you can see, we can extend this design also. We can create a new product, for example, lamp, and it will fit right in without modifying any existing code. All right, so let's go to the code implementation of this. So as you can see, we have created, so this is chair, so chair interface, and this chair has two concrete classes, modern chair and Victorian chair. They are both implementing this chair interface. In C++, there is no keyword called interface, but with the virtual functions or pure virtual functions, we can create interfaces. So chair.cc, if you see sit on, we are saying it is sitting on the modern chair. And for Victorian chair, sitting on a Victorian chair. Similarly, if you look at the coffee table, we are doing exactly the same thing: coffee table interface and modern coffee table and Victorian coffee table. And similarly, sofa, modern sofa and Victorian sofa. Now let's go to the factory, furniture factory. So we first create an interface furniture factory. It has three functions which need to be implemented: create chair, create sofa and create coffee table. And they both return object of type chair, sofa and coffee table. It could be any chair, it could be modern chair, Victorian chair, we don't care. Right now, modern furniture factory implements this, and it will implement these three functions. Similarly, Victorian furniture factory. And now if we see the implementation, the create chair of modern furniture factory returns modern chair, modern sofa and modern coffee table. Similarly, Victorian factory will return the Victorian furniture, chair, sofa and coffee table. So with the code in place, let's see how it all look like. So in the main file, we can see if we create a factory of type modern furniture factory. See, client doesn't need to know what is the type of this furniture factory. Now, whenever client will call create chair, a modern chair will be created, modern sofa will be created and modern coffee table will be created. Similarly, if the client gets Victorian furniture factory, appropriate chair, sofa and coffee table will be created. We can see it also. Okay. Yes. So if you notice, when you do modern chair sit on, it prints sitting on a modern chair. So it's just a variable name, but you can see, right? The sit on is appropriately returning because this chair was created from modern factory. It is saying we are sitting on a modern chair, modern sofa and modern table, putting coffee on modern coffee table. Similarly for the Victorian furniture. Now, as we can see, it is very easy to extend this design. If you want to introduce a new lamp, you can create a class called lamp, and it will have a new file. And in the furniture factory, you will just have one more function called create lamp. So I think we can do it also very quickly. So I will not write the code again. I will just copy paste the previous code. So modern lamp, and Victorian lamp, and now similarly we can create the CC file. And if you don't want to see this, you can just go to the next part of the video. Switching on a modern lamp, switching on a Victorian lamp. So that's it. In the factory we can create a new lamp. We can and each will have to implement it. Create lamp here and here, and finally in the factory so modern factory will create lamp and Victorian factory will also create lamp. And in the CC file, finally, if you create a lamp, right, so you can see how easy was it to extend it, and you can also see that how AI is enabling me to directly writing the code. So now let's see. First we have to build this. Okay, we are getting an error. What is the Victorian lamp? We have to save it, I guess. So we forgot the build. We had to also add it in the build. And in our CC file, I think we have to yes, now it should work. Yes, now it has compiled. And see, switching on a modern lamp, switching on a Victorian lamp. So it was that easy to add any product in this. We have not modified any code. We have just added a new code. So that is why it is an open close principle, open for extension but closed for modification. Similarly, you can create a new family also. You can create a new furniture factory of different style and extend your code accordingly. So I hope this was clear. So now let's come back to the final part, which is the benefit of this. So first benefit is client code has no control on creating the concrete products, which improves your flexibility, right? You can be, and the second is you can be sure that the product you are getting from the factory are compatible with each other, right? Because the factory will always create a product of a same variant. All the products are nicely grouped together, and new products and family of products can be added easily. So it is useful when you don't know all the product types beforehand. All of this we have seen practically in the code, right? So that makes sense. Now the disadvantage, very small disadvantage, is it increases the code complexity, right? We have to create a lot of interfaces, a lot of abstraction is going on, and slight performance impact also due to polymorphism, right? Because on the runtime, compiler has to determine that which function to call to based on the type, It might increase your latency, but in today's systems, the systems are very powerful, and this rarely impact your performance. All right, so now let's go to the last part, difference between factory versus abstract factory. So I've taken this image from Geeks for Geeks. So factory design pattern versus abstract factory. So in factory, we create object without specifying the exact class. Here we create the family of related objects without specifying their concrete classes. So it's just one level above. In the factory, and okay, let's go to the second point. It is less complex because we focus on a single product type. If you have seen my last video, we were creating transport, different type of transports. It is in this abstract factory, it is more complex because it involves multiple products. For example, chair, sofa, coffee table, lamp, or any type of product you can introduce, and any type of family. Factory design is lower level of abstraction, abstract factory is higher level of abstraction. So basically your abstraction is going one layer above, right? So first of all, you don't know which factory you are dealing with, because factories are abstracted, and inside a factory you don't know what type of chair or sofa you are getting, because that is also abstracted away. And the main difference which you can easily notice is, in factory design it involves a single factory method. In abstract factory, it involves multiple factory methods. What are the multiple factory methods? Create chair, create sofa, create table, right? In factory design, there will be only single factory method. So using this, you can easily identify whether it's a factory design pattern or abstract factory design pattern. But nonetheless, they both serve a same purpose, such that you can use interfaces to nicely decouple your concrete classes with the client code. And client doesn't need to know what type of object it is dealing with. So with that, we have covered abstract factory design pattern. I hope with this video you understood what is abstract factory and also the difference between factory and abstract factory. If you like this video, please like this video. If you have any doubts, if you have any comments, please add them down in the comments below. And with that, I'll see you in the next video. Bye.